Good morning, good evening, good afternoon, boys and girls. It's time for IPv6 ACLs. We're going to work on a lab. Let's go. First thing we do, we're going to configure some access lists adding the IPv6. So we will be adding IPv6 integration. This is the addressing scheme. We have 3 routers, 1 server, and 2 PCs. So the first thing we do, we need to access, let me share the topology with you. It is in the other screen. I need to move it around. Router 1, if I'm not mistaken, and we will be doing some configurations there. So let's start with the ACL configuration that we need in this router. And why do we need it for this case? So let's see. We're going to deny www, which is HTTP, for this specific server. So that's the first thing we do. For this specific service, we are going to deny some traffic. Block the HTTP and HTTPS traffic from reaching the server 3. And that's what we will do first. Now, remember, we have to go to config-t, configure terminal, and paste those commands. Am I doing something wrong? Yes, maybe I am doing something wrong here. What do you guys think? Configure the ACL. Okay, we need to configure the ACL, but it doesn't really say how to do it. Do you guys remember how to do it? It shouldn't be that difficult. Let's ask our little friend here, ChatGTP, because we need the first command to configure that specific ACL. And it is IP ACL. Okay, is the same for IPv6? I just want to double check. IPv6. So it's a little bit different. Let's see if this works. We have to go to the specific router. Let me close this tab for now. Give me just a moment, please. I think I closed the incorrect one. So let me just look for the lab real quick. Give me just a break. Okay. So this is what we do. We are going to copy this specific command, the IPv6 command, to block some HTTP traffic. So let me just copy and paste it there in the router. And now we can add the deny command that was giving us some error messages there. Perfect. Same command, but now we have to do 443, which it is for HTTPS. Great. Good job. What else are we missing? Let me close this. We don't need that. Permit any is important. So let's go ahead and do that. Let me just copy and paste it like that. Let's just copy this and paste it in the terminal. And there you go. Amazing. Congratulations. Good job. Now we need to apply it in a specific interface. So let me just copy this, but where are we applying that? In the gigabit 01. Where is that gigabit? Let me see. Preferences. Okay, let's go ahead and be patient. 01 is actually this one right there. So let's go to the topology. And if you go here, this is the one that we are applying the configuration to. So let me change the color to red and let me use the eraser for a moment. We are basically adding to this specific interface. The configuration is actually gigabit 01, where we are adding the changes So let's use the eraser for a moment and let's go ahead and clear the board. Okay, returning to our Cisco packet tracer configuration, we are going to remove those interfaces. We don't need them for now. We were just validating some information. So let's close that. Remove the show labels for the specific interface ports. Be careful because we are working with router 1, most of the changes. So be careful you are configuring in the correct router. Now we apply some of this configuration. Still, we need to apply in the specific interface. IPv6 traffic filter block, HTTP in. Once we apply this, and you can see there is an error here, we have to go on interface gigabit 01, if I'm not mistaken, and apply this over there. Okay, is it the gigabit? Yeah, perfect. Okay, what else do we need? Verify. So we have to go to PC1 and do some testing, try to access those specific networks. So let's go to PC1 and let's do our test here. Let me see. We have to be careful because of the spaces. It's a little bit slow for some reason, but we will survive. Remember to remove the spaces there. Go. It is actually working. Is this supposed to be the result? Let's see. Open and validate. The website should appear. Okay, so apparently the website should appear in PC1, but in PC2 it should be blocked. So let's validate that. Let me share the video for a moment. And let's go ahead and minimize this for a moment. Let me change the IP address and let's click on go. It's pretty much the same. But now, what happened? And let's do a do WR to save the configuration there and close it and close this as well. What happened when we go to PC2 and we do the same test? Let's do it. It should be blocked. According to our calculations, once we apply the same test in the PC, in PC2, it should be blocked. So let's do a go there and let's see if it is actually blocked. Since this is a simulation, we have to be patient. It might take more time than expected. And there you go, requested timeout. Let's remove the S and let's click on go. And in a couple of seconds, you will see the same error message for the timeout. Good. Now the ping should work in PC2. So let me just copy this and let's go to PC2 and validate the ping connectivity tests. Let's go there. Let's find PC2 and let's do that connectivity test. We are sending a ping to this IPv6 address. Look at that. The magic is there. We are able to successfully reach IPv6 address. So that is the IPv6 address for the server. Let's move on. Now we have to create another ACL. So let me ask for help here because it is always important to validate we are doing everything in the correct manner. So first thing we do is IPv6 access list. Let's go to router 3 actually. I was closing, no, I need to go to router 3 to apply that specific ACL. Let's do an enable. After clicking on it, let's close the PC for now. Let's do an enable. Let me paste it there. Let me do a config T, it's important, and now we can paste it. There you go, the access list has been successfully created. Now Next thing we do is a deny ICMP any. That would be for router 3. What are we doing here? We are blocking ICMP on router 3 with some statements. And then we have the implicit deny as always. And we have the permit IPv6 any. So let me go ahead and do that and work on that. What else do we have there? We have to apply it because if we don't apply it, it will not work. So let's go ahead and apply this. Remember, interface gigabit 01. So we go to the right place to apply that. And I was in the incorrect. It's interface gigabit 00. My mistake. Gigabit 00, and there you are able to apply the ACL. IPv6 traffic dash filter block underscore ICMP out. And now we can do the first connectivity test that should fail from PC2. So let's go to PC2 and let's repeat the previous connectivity test. It is unreachable. Now the same test in PC1. So let's go to PC1 and let's complete the same test. Let's do a ping test there. Okay, perfect. Now the last test we have to do is in the web browser of PC1. So we have to go to this IP address. So let's go there. Let me close this for now. Let me return to the PC1 and let's go to the web browser. I'm going to do a brief explanation of IPv4 extended list because there is something that we forgot. We forgot to talk about the ranges for those IP addresses. Maybe we talk about it, but I just want to double check. So just to cover our backs. Let's see, we are able to successfully reach that one. If we click on go, we are able to successfully reach that. Great. Let's just click a random one, like 1.1. Let's click on go. And then we might get an error. I don't know. We'll see. But after that, I want to do the test for this one and the HTTP. Yes, you see the timeout? That is the error. Let's click on go and there you go. I think we're pretty much done with the lab, but before we close for the lab, let me explain about the ACLs. ACLs extended 9-tut. This is a good resource. I want to show you something important before we leave for the day. When we are talking about extended, and I don't see it here, ACL explanation training, there you go. When we're talking about extended, they go from 200 to 299, something like that. We'll see that. Oh, these are the ranges that I want. It's actually from 100 to 199. Let me improve the size so you guys can see it. So this is what we forgot in previous lessons. Maybe we didn't go over those. I want to show you something here. If we're talking about standard, we already knew from 1 to 99 and from 1300 to 1999. Now, the extended access list, we didn't talk about this. The number extended access list, they go from 100 to 199 and from 2000 to 2699. Also, there is the name access list that we have been doing and we have been practicing during the last couple of lessons. But I want to make sure that you were aware and you were informed about these specific ranges for both standard and extended access list. So let me go ahead and clear the drawings for now. Let's see if there's anything else important that we might be missing there. Let me close this. Let's go to number 2. Always apply the interface, the access list in the specific interface, depending on the scenario. If it is a standard or an extended ACL, this case, we were working with an extended ACLs, and we were applying the group in to out in. Oh, that was actually in fast ethernet 00 of the router. Now, we already talked about if we were working with the standard, you have to configure it at some specific point. It was like close to the source, near the source. And for extended, it was near to the destination. It was something like that. I don't remember from top of my head, but we will go ahead and look for that right now. There you go. It's actually backwards. I was saying it backwards. If you are configuring a standard IP access list, it has to be close to the destination, near to the destination. If you are configuring extended ACLs, it has to be near to the source, the specific source. So let me just draw it there so you don't remember. For standard IP access lists, let's say equal, if I am able to do it once in a couple of thousand of years, equal near to, you see it? Destination, near to the destination. There you go. Now, if you go to extended IP access list, and I was missing something important there, access dash list. If we are talking about extended, and I think I was saying it backwards all along, so I apologize for that. Near to the source. So remember that. Standard, near to the destination. Extended, near to the source. Sometimes students get confused about this, and it's important to have these concepts clear so we don't run into trouble and we don't mess around with those. Let me just return for a moment. I was deleting some of that, but this one we need it actually. So I am deleting re-rest. You can take a screenshot right now about this information so you don't forget, because it's very important to remember this. And wildcard mask, we already talked, that is the opposite of the mask, the subnet mask. Is basically, for example, if you have like 255, that, let me just use the other option because I am not so good at writing sometimes. So if you have the 255.255.255.0, the wildcard mask will be 0.255. It will be 0.0.0.255. If you have, for example, what else? What could be another example? If you have 255.255.255.252, the wildcard mask will be 0.0.0.3. So it's pretty much a subtraction that you are doing there. What could be another example? 48, 255.255.255.248. So it would be 0.0.0.7 if I'm not mistaken. So it's actually 3 there, 2 to get to 250, and from 250 to 255 is actually 5. So it will be 007, the wildcard mask. Yeah, that is another important concept, and that is pretty much the basics. But in order to get certified CCNA, you have to have the basic understanding very clear and have all the fundamentals before you go there and take your CCNA certification exam and continue your path in your networking career to become an expert in this branch of technology. So I hope that you have learned from this lesson and that you like the lesson. And remember, practice makes perfect. Let me clear the drawings for now. Until next time, I will see you at the top of success. Boys and girls, it's been a pleasure and take care.